Okay, I checked the mic this time. Okay, so welcome back to Rocket Kyan, my fellow space tubers. Today we have another SpaceX launch, and we have, of course, the Starlink launch, in which the SpaceX push their limits and provide us with a more improved version of rocket, as well as pushing their business to another heights in the same time. So if you don't know SpaceX is a company headed by Elon Musk and is the only private rocket company which is able to retrieve its orbital booster back with their drone ship on their drone ship and then reuse it. And yes, they are human capable, also human space flight capable, and they have very ambitious plans of Mars, moons, and etc. So that's for it. And now let's just have a look at the rocket itself. So guys, we have Falcon 9 rocket as the uh, uh, rocket, yeah, vehicle this time. So it has 89 total launches, 50 total landings, and 35 reflown uh, rockets. Okay, so Falcon 9 is a reusable two-stage rocket. Okay, as you can see here from this, wait a sec, just, yeah, so this is a two-stage rocket. Let me just describe all the parts of it. Here we have the fairings, and in which the payload sits. Today we have a payload, the Starlink satellites, as well as two planet sky satellites. Okay, so and this is the second stage. This is the interstage adapter. These are the grid fins. This is the first stage, and 9 Merlin engines and the landing legs. Okay, so it has 22.8 tons to the orbit. This is their, you can say, the smallest rocket. SpaceX, in quotes, the smallest rocket, but yet so powerful, 22.8 tons to low Earth orbit and 8.3 tons to geotransfer orbit. So it's a very powerful rocket, as we can see. Then there comes the Falcon 9 first stage. It has 9 Merlin engines, as this diagram says. It has 9 Merlin engines which runs on RP1 and liquid oxygen as its propellant. Okay, and we have landing legs for this. It has the thrust at the sea level is 7.607 kilonewtons. Okay, that's the thing. Then the landing legs. These landing legs support the first stage booster when it comes back to the drone ship after re-entry from the atmosphere. Okay. Then we have the second stage. The second stage is powered by one Merlin engine, which is a vacuum optimized Merlin engine, which has a bigger bell, because bigger bell is needed as to push its efficiency to the next level, as when the bell the pressure of the uh, gas coming out of the bell matches the surrounding pressure, I should say the surrounding pressure, then the efficiency of the rocket is maximum. So that's why, to decrease the pressure, and we can't achieve zero atmospheric pressure, but to decrease the pressure to much of the extent, that's why we have a larger bell. Okay, so yeah, that's the thing here. And for the second stage, then we have interstage, which the grid with the grid fins. Grid fins are needed so as to guide this first stage rocket, which will be coming back to the Earth from the suborbital trajectory, and during aerodynamic re-entry. So these fins during aerodynamic re-entry guide the first stage to its landing location, that is the drone ship. Okay, then we have the payload at the 5.2 meter diameter fairing, and height is 13 meters. Okay, so that's the thing. Then we have the Merlin engine. We have, as you can see, this is the pre-burner. This is the Merlin engine itself, and it runs on LOX and RP1, and this is the the vacuum optimized. So as you can see, the bell size has increased significantly, and the bell size is so much you can't even imagine. Okay, this in the picture it looks very small, but it is very big, very big indeed, I should say that. Now we should have a look at the mission profile. So hi Ken, hi Wilmer, good morning Wilmer, how are you, and how are you Ken? So have a look at the mission profile. So this is how what will happen today. We will have a launch. Then of course the ascent will be like this only. The rocket just don't go straight up. It goes straight up to gain height, but but it has to get into an orbit, and to get into an orbit we goes sideways. That's what it is being demonstrated here. Ascent, then here we will have the MECO, the stage separation, and the second engine start. This is where it comes, and then here the second stage goes. For the first stage, it performs a flip maneuver, faces retrograde, and then fire up its engine. This is the entry burn, which lasts around 10 to 20 seconds so as to slow down the rocket to prevent the aerodynamic, you can say, re-entry damage. Yeah. So, and then finally the aerodynamic guidance to guide it towards the autonomous drone ship, and then finally propulsively it will land. And for the second stage, the fairing separation will occur after this, and then the payload separation. Okay, so that's what we have. So as you can see, the second stage engine cutoff SECO we will be having. Then SkySat, three SkySats will be deployed, 21, 20 and 19, and then the Starlink satellites will be deployed. So first those three will be deployed, and then the Starlink satellites will be deployed. So it's a big mission. So let's just have a look at as in what is Starlink. So this is Starlink. As you can see, guys, uh, Starlink is basically you can say satellite. Of course it's a satellite. It's a constellation of satellite which the company is aiming around 42,000 constellation of satellites to provide high speed low latency internet anywhere in the world. You don't need to be in you can say if you are in the rural area, or nothing is happening, nothing is there in around you, like you live in a place where you don't even have an access to electricity, then also you will get an internet. Okay, because the internet will be directly from the satellite, not from anything else. So why is it important and why is it unique? Because the Starlink altitude is 550 kilometer, and the other satellites which currently provide the internet has 1000 kilometer plus altitude. Since the altitude is less, hence the latency of the internet decreases significantly. That's what it is. So this is how the stack of the Starlink satellites look like. And we have those antennas, of course, singular solar panel array, ion propulsion system it has, so to reach the designated orbit after deployment, star tracker so as to uh, orient itself in space, autonomous collision avoidance to avoid the collision, and that's all for this thing. Let me just now see if we have, no, we didn't have the we are still waiting for the SpaceX to start the stream, but yeah. So yeah guys, that's what it is. So one more thing, as you can see, this solar panels, and because of the solar panel, as you can see, solar panel is made up of glass and it's very shiny, and because of shiny nature of these satellites, the company, the SpaceX itself has been given so many of criticism, as in it will spoil the night sky, it will you can say become a hurdle for the astronomers and other people like them. So to you can say reduce that criticism and all, what SpaceX has done, SpaceX has introduced the solar sunshade, I should say sunshade. If I am not wrong, there was something regarding that here also. We don't have here, okay, no problem, but it has sunshade which basically reduces those shiny thing significantly, and hence uh, you can say, and meeting all those demands and providing the internet, and uh, the astrophysicists also be happy. That's what they aim, but I don't know. So, hi Luis Carter and hi Milena. I don't speak Russian, so I'm really sorry. I don't know what you said, but that's what we have. We are just wait a sec, guys. Let me just switch over to the stream. We are waiting for the stream to happen, and it will happen anytime now. Mm-mm. Oops. Yeah. Now it's good. Okay. So guys, we are 16 minutes from the launch and yes, Luis Carter, I am totally well and fine and we just waiting for the uh, SpaceX to start their stream. Only 60 minutes left. They around they start their stream around 10 minutes or so, 10 to 12 minutes, and we should be having the stream now. No, what the hell has happened? Because it starts 5 minutes before 10 minutes, as in they gather all those people, like, right? So, waiting for the stream to happen. And so, how are you guys? Just tell me that, and we'll be seeing all those streams and all. But how are you guys? Seeing so happy that we have internationally audience coming in and listening to all those things which I say. Feels very good to know that it provides as in like a platform to distinguish everything and all, right? And learn some rocket science and watch the launches itself. Maybe we can do one thing till that, since it is taking some time. So let me just switch over to that and we can have a look at it. What if we people, oops. Oh yeah, one thing I forgot to tell you, I should tell you right now. Oh, SpaceX is live. Let's Okay, so this is what I was telling, guys. This. This is today's we have a rideshare mission, as you know, and this is what we have for the rideshare mission to happen. This is the this is their rideshare mission guide, and here we, as you can see, 15-inch port mass of up to 454 kg and 24-inch port of 830 kg. This is to uh, book your ride on 15-inch or 24-inch. You can say that's whatever you want to enable those things, but today I think we will be using this one, if I'm not wrong, this space here. I don't know much about it, but yeah, that's the thing. So let's just switch over to the stream now. Oh, 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 oh. And there we go. So here we are. That's what we are here for, right, Ken? To learn some rocket science and all. Oops. Okay, so here we are. I don't know why the SpaceX is taking so much of time today. They don't usually do, but yeah, we are here. And we will be witnessing today a morning launch at around 11 p.m. in their time, in EDT time.
Good morning. It's Tuesday, August 18th, and you're looking at a live view of Falcon 9 as it awaits its 10:31 a.m. Eastern Time launch from pad Slick 40 at our Cape Canaveral launch site in Florida. Hello from SpaceX headquarters in Hawthorne, California. My name is Kate Tice, and I'm a senior certification engineer here at SpaceX. You're watching a live webcast for our 11th Starlink mission. This morning's launch represents a couple of milestones: our 14th mission of 2020, our 90th Falcon 9 mission, and the first time for reusing a booster for the 6th time.
I forgot about it.
To date, we've launched nearly 600 Starlink satellites to orbit. As a reminder, Starlink is a constellation of satellites that can provide high-speed, low-latency internet all over the globe, particularly in remote or rural areas where connectivity is limited or completely unavailable. We have 3 small sat passengers on board today's mission for our customer Planet, the operators of the largest constellation of Earth observation satellites. You may remember we also successfully launched 3 SkySats for Planet on a Starlink mission in June earlier this year. The satellites on today's mission will enable high-resolution imaging of a single location up to 12 times a day. They'll be joining 18 SkySats already in orbit, completing Planet's fleet of 21 satellites, making it the largest high-resolution fleet of satellites in orbit to date. Now, in order to make room for those 3 rideshare passengers, we will be launching 58 Starlink satellites today into low Earth orbit instead of the usual 60, as we have done in the past. Planet's SkySats will deploy in 3 sequential maneuvers beginning at about 12.5 minutes after liftoff, and the Starlink satellites will deploy at 46 minutes after liftoff. So at this point, we're at just under 8.5 minutes until liftoff, and right now all systems are go for an on-time liftoff this morning.
We have very completely forgot to tell you guys that this is the first time the SpaceX will be using their booster for the 6th time.
There on your screen
So it's
is
very
Falcon
important
9,
milestone
our
to achieve
two-stage
today.
liquid-fueled launch vehicle, getting ready for launch from Space Launch Complex 40 or Slick 40 in Cape Canaveral, Florida. Falcon 9 stands 70 meters tall, which is just greater than the wingspan of a 747 aircraft. Today's flight will be the 6th flight for this booster. It previously supported the Telstar 18 VANTAGE mission, Iridium 8, the first Starlink mission, as well as the 3rd and 8th Starlink missions. And this will mark the first time that we're flying a booster for its 6th mission. The bottom 2/3 of the vehicle that you see there is the first stage. And if you look closely, you can actually see the white clouds there are covering it up at the moment, but there are soot markings still on the vehicle from its previous 5 flights. The first stage has 9 Merlin engines that do the bulk of the work to get Falcon 9 off the ground and up into the thinner parts of the Earth's atmosphere before separating from second stage and making its way back down to Earth for landing. Today we will be attempting to recover this first stage for the 6th time. This time we'll be doing that on our drone ship, Of Course I Still Love You, which is currently stationed in the Atlantic Ocean. You can see it there on your screen, about 350 nautical miles northeast of our Cape Canaveral, Florida launch site. On top of the first stage is the inner stage, which is the black segment of the rocket that you see there. The reason it's black as opposed to the rest of the vehicle is because it is unpainted TPS, or thermal protective system. And that TPS is what protects the composite material in which the inner stage is made out of. The inner stage is what connects the first stage to the second stage and protects the second stage's single Merlin vacuum, or MVAC engine during launch. That MVAC engine ignites after the first stage separates and will propel the second stage along with Planet's 3 SkySats and our 58 Starlink satellites into an elliptical orbit above Earth's surface. Like I mentioned earlier, Planet's SkySats will deploy sequentially at about 12 minutes and 30 seconds after liftoff, and our Starlink satellites will deploy around T plus 46 minutes.
Yes, high river research,
Falcon
they
9
will
has
be
been
recovering.
loading propellant since T minus 35 minutes. As a reminder, Falcon 9 uses a rocket-grade kerosene, which we call RP1, for our fuel, and super-chilled liquid oxygen, or LOX, as our oxidizer. Currently, RP1 and LOX are nearly fully loaded on both stages, and liquid oxygen will continue to be topped off right until the last minutes of the countdown. The stack of 58 Starlink satellites and 3 SkySats are safely enclosed right inside of that structure, our payload fairing, which is a 17-foot diameter structure at the top of the rocket. The fairing protects the satellites from aerothermal heating, aerodynamic loads, and contamination during the ascent phase. Once we reach the vacuum of space, we'll jettison those fairing halves while the second stage will continue on to orbit. The fairing halves that we're using today previously flew on the Starlink mission that we launched earlier this year in January. We will be attempting to recover these fairing halves today using our recovery ships, which you can see there on your screen, Ms. Chief and Ms. Tree. At approximately T plus 40 minutes, or roughly 2 minutes before landing, the recovery team will perform a poll to confirm if we're good to make a safe catch attempt. As you might imagine, weather plays a big factor into that go, no-go decision for the catch attempt, as it can impact not only the sea states for the boats, but also the fairing's altitude, position, and speed, which impact all how the fairing will fall back to Earth. As of right now, weather is looking good. We have got blue skies and just a couple of clouds there at Cape Canaveral, Florida. The vehicle, the satellites, and the weather and the range are all looking good for an on-time liftoff of 10:31 a.m. Eastern at just under 4 minutes from now.
So, guys, the stream of the fairing will depend on how much capable they are.
For those of you that might be newer
fairing.
to the Starlink program, little info for you. Our mission is to bring high-speed, low-latency internet to people all over Earth. Every one of these Starlink missions gets us closer to achieving that goal. Some of the most exciting opportunities for Starlink are locations where traditional fiber or cable is simply not practical, such as rural and remote communities. It's also exciting for places where fiber and cable are impossible, such as aircrafts and cruise ships. This is a big endeavor, and we have a lot of work ahead of us, but today's launch gets us one step closer to these goals. If you're interested in getting future news about our Starlink service, head on over to starlink.com and sign up for updates. And if you're interested in helping roll out Starlink to the world, our Redmond, Washington location, which is just outside of Seattle, is looking for talented software engineers. The software engineers here at SpaceX get to drive work across exciting projects such as our rockets, spacecrafts, and satellites and ground systems. Send your resume to softwarejobs@spacex.com if you're interested in joining our team. So right now, we are just under 2.5 minutes from liftoff, and Falcon 9 is moving into the final stages of the countdown. Right now, the first and second stages are nearly fully loaded with 1 million pounds of kerosene fuel and liquid oxygen. Fuel is completely loaded. LOX on the first stage is also completely loaded, and we are continuing to top off the liquid oxygen loading on the second stage. Super chilled liquid oxygen, which, like I mentioned, we call LOX, is our propellant oxidizer, and that's what is creating those white clouds around the vehicle that you see there. This happens when liquid oxygen is exposed to ambient air, which is warmer, and causes the liquid oxygen to evaporate into gas and form those white clouds. The first stage should finish prop loading here, and actually, I just noticed that all fuel tanks and liquid oxygen tanks are now fully loaded, so complete there on the prop load. Here, in just 30 seconds or so, we'll hear a call out that Falcon 9 is in startup. It means that the rocket's autonomous internal flight computers have taken over the launch countdown. At T-minus 2 seconds, the Merlin engines will light, and liftoff will be commanded to the vehicle at T-minus 0. So right now, as we approach the T-minus 1 minute mark, the Starlink payload and the Planet payloads continue to look healthy. Falcon 9 team is tracking no issues on the rocket. Weather continues to look good, and the range is green for launch.
Falcon 9 is in startup.
So guys, only 1 minute is left for the launch.
Stage 2, press for flight.
So
LDs go for launch.
So we have launch director go for launch, hence we will be seeing this rocket flying today. I'm so excited seconds. Now. 30 seconds, 29, 25 seconds, 24, 23, 22, 21, 20, 19.
Okay, so we're
80,
in the final phases of
70,
the countdown. Let's
Stage
watch
1
as Falcon
16,
9 takes
15
15 Starlink satellites
14,
and 3 Planet SkySats
13,
to orbit.
12, 11,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
ignition,
And liftoff of the Falcon 9. Go Starlink.
and liftoff of the Falcon 9 vehicle carrying the Starlink satellites and the Planet Sky satellites to the orbit. Here we go for a beautiful liftoff, guys. Propulsion is nominal, and we can see this rocket booster, the first stage, which is a pretty old but doesn't look old in its performance. It is performing very significantly and properly. And next event coming up is the Max Q. So Max Q means the maximum aerodynamic pressure that the vehicle experiences during its
successful
ascent.
liftoff of Falcon 9
Power
from
telemetry
Space
nominal.
Launch Complex 40 for this
Wow.
11th Starlink mission. The 3 Planet SkySats and our 58 Starlink satellites are on their way to space.
Wow.
In
So
about
now
10 seconds, we will be approaching Max Q.
of course,
Merlin engines
Vehicle
are now throttling
supersonic.
down as they anticipate the moment of greatest aerodynamic pressure.
and I cross, and here we go for the
Max Q.
conference.
All right, we just went through Max Q, and the vehicle is now supersonic. And Merlin engines have throttled back up.
Guys,
So
and
coming up in about a minute, we'll have 3 events happening back to back. First will be main engine cutoff, or MECO. This is where all 9 Merlin engines will shut off to slow the vehicle down in preparation for the second event, stage separation. This is where the first stage separates from the second stage, with stage 1 starting to make its way back to Earth for landing, while second stage will kick off the third event in this sequence, SES-1, or Second Engine Start 1. This is where that Merlin vacuum engine will ignite and begin to propel the second stage along with our payloads into orbit.
And guys, this
Main
mission
engine cutoff coming up in about 20 seconds.
is very important, because if this booster survives the landing also, then this booster can be reused for the 7th time. That will be another
Continuing to
milestone.
look nominal for stage 1.
So now the MECO is approaching, as we know. MECO in MECO. Here we go.
Yeah, Miko.
And
Stage separation
confirmed. And second engine start 1 confirmed.
Back ignition.
All right, so there we saw those 3 events all happen in quick succession.
Now we will be seeing
Stage
the
1 is now making its way back to Earth. There on
jet.
the left-hand side of your screen, we can see the grid fins slowly deploying. And
Now
on the
we'll be
right-hand
seeing the
side of your
jettison of
screen,
the
the
fairing.
Merlin vacuum engine beginning to develop that healthy orange glow as it continues its journey on to orbit.
Fairing separation confirmed.
We're just a few
Fairing
seconds away from fairing deployment.
separation confirmed.
There we go, visual confirmation of fairing deployment. Once again, as a reminder, we flew those fairings on a previous Starlink mission in January earlier this year.
Guys,
So with that, we have successfully reused this fairing pair.
so
Like
yeah,
I said earlier, we will be attempting to catch those fairing halves with our recovery ships, Ms. Tree and Ms. Chief.
exactly. And the stream will depend on 2 factors. The network should be proper there, and
Review the
also
acquisition of
Everything
signal.
continuing nominally.
the if they are probable enough that they will catch the fairings, then of course they will stream that part also. But if they are not, then they won't. The main thing which I'm looking forward to is the landing, and I want this landing to be very, very, very
While the
successful.
second stage is continuing to do its job, the first stage is making its way back home to Earth. In the next few minutes, it will be executing 2 burns. The first is the entry burn, where 3 of the Merlin engines at the bottom of the first stage will light up and begin to slow the stage down as it re-enters the upper part of the Earth's atmosphere. The second burn is known as the landing burn. This is a single engine burn that will bring the vehicle speed down rapidly in order to make a soft landing on the drone ship.
That single engine is capable enough to land this huge monstrous first stage booster to the drone ship. The
The
first stage
58 Starlink satellites that
trajectory.
are being carried along on the right-hand side of your screen there by the second stage will be joining our constellation of over 600 Starlink satellites that are already on orbit, which once again are designed to provide high-speed, low-latency internet to people on Earth.
Yeah, so the
This is
height of
particularly
the
important for
first
places
stage
where
booster,
good
guys,
internet is hard to access,
is
as well
around
as places where
10-story building.
wired or grounded internet is impossible, such as ships and airplanes.
That's what
We're
the
1
size
minute
of
away
this
from the
booster
beginning
is.
of that entry burn. On the left-hand side of your screen, we can see stage 1 coasting. Using nothing but those grid fins, we see them articulate here and there as they continue to steer. And we also utilize nitrogen gas for occasional little bursts of that nitrogen gas, and we use that for attitude control, which sometimes you can catch a glimpse of as little white puffs.
So now the next event coming
Second
up is the
stage
entry burn
continuing
in
nominally,
just few seconds.
now
the
at
entry burn-
1.5 Gs for acceleration.
Okay. So entry burn will last around 10 to 20 seconds, guys. and after that I don't want the signal to lose.
10 seconds away now from the beginning of that entry burn. Again, this is the first of 2 burns intended to slow the vehicle's velocity
Stage
down
1
as it
FTS is
re-enters
saved.
the Earth's atmosphere.
Stage 1 entry burn startup.
Entry burn has started, guys.
And there we can see that the entry burn has begun and will last for about 20 seconds.
Okay, and please, I want the successful landing of
Stage
this
2
booster.
continues on nominal trajectory.
Again, this burn utilizes 3 engines at the base of the rocket. And
Stage
there
1
we
entry
can
burn
see the
shutdown.
entry burn has concluded.
Entry burn has concluded and we haven't lost the signal, guys.
Second stage trajectory is still looking nominal.
That's so good, and I don't want the signal to be lost, please. I want some aerodynamics to be seen here. Wow, please don't lose this.
And in less than a minute, we will see the first stage
Okay.
on the left-hand side of the screen perform its landing burn. Looking back at our second stage, everything continues to look good. Once again, we are carrying 58 Starlink satellites prepared to join the over 600 Starlink satellites that are already on
Stage 1
orbit,
transonic.
as well as 3 rideshare satellites for our customer planets. Those 3 SkySats will join the 18 SkySats that are already also on orbit. We're about 15 seconds away from landing burn.
Terminal
Oh.
guidance.
We want the visuals from the drone ship right now.
Stage 1 landing burn.
Yeah, here we go. Something is coming up on this
And
as we
landing burn
can
has begun.
feel from the vibrations. Please land on
You
this
should
drone
see the plume
ship.
from the
Yes,
rocket
saved.
appear on the screen here.
Stage
in
1 landing leg
second.
deploy.
Landing legs deployed and
Our touchdown and shut off.
wow!
Successful
Stage 1 landing
landing
confirmed.
of the first stage booster.
The first
Once
stage
again, this is
has
the 6th time
landed.
that we have utilized this booster on a mission, also marking its 6th landing.
This
This
is
is the
so
Of Course I Still
good.
Love You drone ship in the Atlantic Ocean.
Finally, the thing which was the weakest point of the mission, you can say, is completed successfully, and also the
So turning our
second
attention
stage.
back to second
Yes,
stage, we've
cut off.
had
Nominal
confirmation
orbit insertion.
of second engine cutoff, or SECO-1. And we also have confirmation of a good
Useful
orbit.
acquisition of
So now that stage 2 is going to coast in this orbit for another 3.5 minutes, we're going to take a quick break, and we'll be back at T plus 12 minutes for the deployment of Planet's 3 SkySats.
Wow, guys, that was so cool. That thing landing, I really doubted that landing will be possible, because in the previous mission in which the fifth time they were landing, if I'm not wrong, they had some issues with the landing and they lost the booster. But here, bingo, as Harry Racer said, we had no problem in the landing, and finally we will be seeing that Falcon 9 booster again supporting the Starlink satellite mission for its 7th time, and those boosters are made to last for 10 times, so 10 times they can be reused. So I am looking forward to that. And also, guys, one more thing I would like to say, just think of that time when the SpaceX will be utilizing its Falcon 9 booster for the 10th time. Since these boosters are rated for 10 times reusable, then would it reuse for 11th time? As in, they do, if it is rated only for 10 times, right? So would it reuse for 11th time? Means would they perform a landing? I doubt that. Maybe at that time we could see one fully expendable mission of the Falcon 9 booster, as in no recovery or no landing, because it would be impractical to land the first stage booster. I don't know. Maybe they can they can land that booster and use that for some R&D purpose, and so but it is a thing, it is a, you can say, a food for thought. And high river racer, the telemetry, okay, the telemetry is there on the first stage booster. It is not like doesn't have it, but the only thing is when it's re-enter the atmosphere, right, the plasma buildup, or you can say when the vehicle is so much transonic, then there is problem with the signal acquisition, or signal, you can say, the or telemetry.
For this 11th Starlink mission, we had an on-time liftoff from Cape Canaveral, and everything is looking nominal for our second stage. As we can see on our screen there, the stack of payloads. We are carrying 58 Starlink satellites, as well as 3 rideshare satellites for our customer planet. We're about 10 seconds away from the first of 3 deployments for those planet SkySats.
The sky, okay, the one should happen now.
SkySat 21 deploy confirmed.
First one, and we can see
Okay,
it also.
deployment confirmed for that first SkySat.
Wow, these are
The
rare to
first
see.
of 3 this morning. And there on your screen, at the end of the stack, slowly making its way.
This is a
away
cube
from
set,
the
guys,
second
as you can
stage.
see
We
only.
can see that first SkySat moving along.
This is so cool, right? Just to see one satellite going.
SkySat 20 deploy confirmed.
And confirmation that the second SkySat has deployed. We'll see that here momentarily. Ah, there it is at
And
the
here we go for
end
the
of the stack
second one.
again. And awaiting the third and final deployment for this rideshare customer.
And SkySat 19 deploy confirmed.
And deployment confirmed for that third and final SkySat for our customer planet. These 3 SkySats will be joining 18 already on orbit, which will complete the fleet of 21 and make it the largest high-resolution fleet of satellites in orbit to date. Like I mentioned before, they'll be capable of imaging a single location up to 12 times a day.
Wow.
Right now, stage 2 is going to continue to coast in this orbit for a few more minutes. During this time, it will start to spin along its central axis, which will give those Starlink satellites the momentum they require to space themselves out over time after deployment at T plus 46 minutes. So right now, we're going to take a break, but stay tuned because we'll be back at T plus 45 minutes in preparation for the deployment of those 58 Starlink satellites. Stay with us.
Okay. So yeah, so what she said right now, the spinning of the Starlink satellites, let me just explain you a bit about that. Guys, the spinning is required. So let me just tell you what that spinning does. That spinning basically is used to separate all the stack of the 58 Starlink satellites. So how does it separate? Let me just explain you with one experiment. Okay, do this thing. Take one rock and tie it on a string and then rotate that string. What happens? When you rotate that string, after that, when you if you release that string, then it goes away, right? That's what it does. This thing does. It rotates that all those Starlink satellites slowly and slowly. So what happens? All those Starlink satellites require some velocity, angular velocity I should say, and that angular velocity has difference in them because the angular velocity depends upon the distance from the rotation, center of rotation, you can say, center of axis of rotation. Yeah. So far more velocity it will have, less velocity it will have. So because of this velocity difference, the speed at which they are ejected out from the spinning stack is different. So because of that, they separate from each other. That's the thing. Okay, Aman wants to say something. The SpaceX Starlink project is a business. Okay, so let me come. I don't want to comment on it, but I would like to share my views on it for sure. See, maybe this could be a business kind of a thing, but this rocket bill, you can say the SpaceX is profiting in this from two ways. First of all, they are testing all the capabilities of their Falcon 9 booster, which is like a thing to be done. Okay, they can't do it for other customers. They can do it only for the Starlink satellites, because if something goes wrong, then they will lose their own payload only. Yes, that's one thing. And the second thing is, of course, the Starlink constellation will increase their business and give them more money for futuristic development, like in Starship. We know their heavy booster, the Starship, and all. So, but other thing is also that we will be getting the internet finally. Okay, and people have started getting the internet for the beta program. The beta testers are there, and they are getting the speeds of around 11 mbps to 60 mbps per second, and that B is small, so it is bits per second, not bytes per second. So just a fun fact for those who don't know, what network companies shows mostly is small b. If you ask the company what's the speed of your network connection, they'll say 100 mbps. Okay, and when they'll show you, they'll also write small b. That small b is means bits. Okay, and bigger B, the capital B, means bytes, and one byte has 8 bits. And the thing which you see normally for the downloading and uploading and all those storage, 50 MB, 60 MB, that has bigger B, capital B. So what it means is, if you are getting 100 mbps for a small b, then actually you are getting 25 megabytes per second. That is the actual speed which you will getting, not 100 but 25. That's the fun fact for that. Okay, so yeah, coming back to the topic, so that's what was the speed. And the latency was around 21 milliseconds. That was that. And regarding the light pollution for the sky, yes, I am also worried about that. As in, it will spoil the night sky for those who want to observe the night sky. But SpaceX is doing stuff for that, as in they have applied sunshade and doing more optimization, as in they have also changed the angle of the solar panels for the satellite. What it means is, it won't reflect much to that light won't reflect much towards the earth. That's what they have done for that. And regarding the space junk, well, I would say one thing only, they have a propulsion in them, right? If something happens with them and something is wrong with them, as in if they expire, their lifetime is done, then the propulsion system will let them deorbit from their particular orbit. So regarding the space junk, I wouldn't say that will happen. The other thing regarding that will happen, as in the space will be polluted for other rockets to fly, because they will be needing to locate for that if any Starlink satellite is crossing that point of ascent or not. So yeah, that will happen, that will surely happen there, but that you can say was bound to happen, I would say. Not by if not by Starlink, but by other companies. That was a thing which was to happen eventually, because as you can see, as rocket or you can say the space is becoming more and more accessible, more and more companies are accessing space and harvesting its resources, right? So many satellites will be launched eventually. So you can say, okay, that thing will happen, but I don't know. That's what it is. If we are able to get internet on the earth without any problems, then I would say it will be a good trade-off. But yeah, also for their collision and all, for if you are thinking of the Kessler syndrome. And for those who don't know the Kessler syndrome is that when the chain of reaction is occurred in the space, as in when two satellites collide, they will make debris, right? They will cause debris, and those debris will hit other satellites, and that will also crash, and that will also produce debris, and that debris will hit more satellites. So all the space will be covered with debris only, and then at that time we will be locked on the earth. We won't be able to access the space afterwards, because every time the debris will be revolving around over our head, and we won't be able to pass it. But yeah, that's a thing which we should be worried about, and we don't have right now any practical debris removal program of any space agency in this world. We do have proofs, as in the we have published papers, and we have the concept, but no one has in particularly standed up for this cause, as in cleaning up the space for the old satellites and other things, so as to reduce the chances of the Kessler syndrome. Yes, but that will be there for the geostationary orbit, and the geostationary orbit is very much polluted, as because that orbit is like very much in altitude, and that's why we don't have any drag from the Earth's atmosphere, which does not deplete its orbit to a much extent, hence they remain in that orbit only. But yeah, but there are very little satellites in geostationary orbit. Most of the things are in the low Earth orbit. That's the thing. Well, the biggest money maker for the space business will be the space asteroid mining, guys. If anyone can figure out asteroid mining and harvesting the resources of the asteroid, well, I remember the Neil deGrasse Tyson's one quote: the first trillionaire of this world will be that man who will be like able to figure out asteroid mining. So that's the thing, and people have started doing work for that, because in asteroid we have plethora of resources. Like, we don't have any limit. Theoretically or practically, you can say we have unlimited resources in space, unlimited, and if we can harvest that for our own benefit, then we will, you can say, save our planet Earth from depleting. As in, if for example, gold mining, which happens in Earth, it causes many problems, as in the soil pollution, air pollution, and other most of the things. But if we can harvest that gold from any asteroid, then all those things will be like very, very, very mean to us. Once we are okay, let me just tell you this thing also. Once we started doing asteroid mining, then all those things which we are doing right now in the earth, extracting resources from the earth, if we do that by that time when we have done asteroid mining, then it will feel like, why we are doing this? This is so rude, so cruel for the planet. The people will be like this: whatever resources we want, go to asteroid and have it now. It will, the behavior of people will change like this. That's what and the best example to explain is when the Falcon 9 made its first propulsive landing. Everyone was like, nah, it is not possible to propulsively land an orbital class booster, and they made it. People were like, okay, if you want to reuse the boosters and all, you can use parachutes, do the parachute. Why are you going for propulsive landing? Everyone was like that only, go for parachutes and all. But no, SpaceX went for the propulsive landing, and they accomplished it. Now Rocket Lab is using parachutes for their booster recovery. They are planning to do that, and everyone is like, why aren't they using propulsive landing for their recovery? So that's how that attitude of the people changes. Yes, Luis Carter, I know that we have STB9D docking undocking sequence today, and if you want, I could stream that also. We could learn from that, something from that also. Ken, asteroids are not flat or round; they are uneven, as in a shape of a rock, but a bigger size. They can be small as small as you can say size of a rock, and big as in a whole city, as whole city or whole country. So that's how big they are, and they have plethora of resources in them. I can't even tell you how much resources they contain, and if we are able to manage and control and harvest all those resources and get back them to earth, then it will be like, wow, something has done, something is there. High River Racer, who is in final preparation of landing a vehicle. Who is that? I know that JAXA's Hayabusa mission did that. They went to an asteroid, landed on them, and collected one sample, and then that Hayabusa is now its way back on the Earth, and then that will drop its sample, and they will collect that sample, and that sample, if I'm not wrong, will be distributed to NASA and JAXA in some proportion. So yeah, the Hayabusa mission is doing that, as in taking but asteroid mining is not there. They are just going there and having the sample collection. One thing I would like to say is, if you would like if you are like, guys, asteroid mining, is there anything new technology involved in this? I would say no. We already have all those technologies available on the earth, and we already know everything. How do we go about and do that? But the only thing is economic factor, as in going to that asteroid, taking that asteroid to low earth orbit, and then mining the resources and then getting back to the earth will cost a lot more than just going to the mine and extracting the resources. That's the thing. Yeah, space fills everyone's time because it's a thing which needs to be explored so much that we I'm so very amazed about the space and all those things. NASA's Asteroid Explorer. NASA sent one OSIRIS-REx mission, if I'm not wrong. Was it OSIRIS-REx? Or is it the OSIRIS-REx was the name of the asteroid? I don't know. But they are they are not for the mining and all. That is another concept. Okay, so now what NASA is doing for this mission, OSIRIS-REx, they are researching on a way to, you can say, change the orbit of any asteroid which is in danger for the Earth, as in colliding towards the Earth. If we can figure out any asteroid which is in probability of hitting the Earth one day and change the orbit of that asteroid and saving the whole planet, then that would be a great deal, right? we will be thankful to NASA, right? So that's what they are doing it. They are researching for that thing, and right now they are orbiting the asteroid, and yeah, they are preparing for the sampling also, landing on it and taking the sample. Yes, Blues Traveler is right. Yes. OSIRIS-REx mission, and if I'm not wrong, they are very close to land on it and taking the sample. That's the thing. Right now they were just like orbiting the asteroid, and orbiting the asteroid takes a very much big deal, because asteroid does not have any mass on it, very little mass. So they need to uh, always, and the orbit of the asteroid, orbit around the asteroid is very sensitive. They always need to correct their orbit. The spacecraft always need to correct its orbit from the solar radiation, solar wind pressure, the also from the heat coming out of the asteroid. That also causes the disruption of the orbit of the spacecraft orbiting the asteroid. So that's how much sensitive the orbit is. Thanks Blues Traveler for the information. Yes, it is. The OSIRIS-REx mission is that in which they will be doing that. And yeah. One more thing I was to say, yeah. The space is the future, guys. If I am not wrong, the space is the future. Right now, the space is the future. Gravity-less environment is also one very great resource, as in we are able to print organs, literally 3D print organs in space. We can't do that in on Earth, because what happens if we try to do that on Earth, the layers of the cells for an organ, they just come down, and because of the gravity they come down and collapses. That whole structure of that organ collapses. But in space we don't have gravity. We do have gravity, but we are weightless. Obviously we have gravity does not go away, but we are weightless. Because of that, the layers don't collapse, and because the layers don't collapse, we are able to 3D print the organs. Literally we are able to 3D print the organs. Would leave the booster in orbit, fill it up with asteroid gold, and then land it, then do first of all, getting an asteroid near Earth in a low Earth orbit would be very risky, because what if it could come down because of the orbital depredation? That will bound to happen. That will happen for sure. And what if it goes down and hit the Earth instead? So we should be very, very careful about that. Of course, Elon Musk is today's Da Vinci. Elon Musk is like a person who is a futuristic person. A person like him comes in centuries, and I really admire him. He's my inspiration, and he's the only one person whom I admire the most right now. OSIRIS-REx 2 is a 3D print. Oh, we have 3D printing in space. Also, if you are not not into satellite internet, then we have also one more thing in space which is being manufactured right now. Also, manufacturing in space is also one thing. We have many things in space, guys. We have many things in space. So I would say one thing which is being researched right now: fiber optic cables you use for the internet, guys. Okay. So right now they have one problem, not problem, I would say a better alternative to them is available right now, but the only problem with them is if we manufacture them here in a gravity environment, what happens, the structure of the that cable, you can say, is very polluting for the light or the signal to travel through it. Okay, but if we manufacture that in space, that does not happen. So we will be able to get more high speed internet with the cables if we are able to manufacture that in thing. Yes, Ken. And I was like, whoa, what will I do in this in so much of time interval, as in 45 minutes we are 30 minutes or so, what we will do in that? And we are discussing a lot about it. Okay, so as the asteroids are interesting, the comets are also interesting, and the best mission to describe the comet is the Rosetta mission of ESA. That's for ESA, not NASA. They went to 67P comet, if I'm not wrong, and they took pictures of that, orbited that, even landed on it, and then crashed their Rosetta spacecraft on it. So it was also a very interesting mission. And also one more thing, guys, if you are let me just tell you one more thing, that is also one thing interesting. Just wait a sec. Oh yeah. So let me just tell you one thing, guys. Before, if you have you seen Pluto, as in the image of the Pluto? Have you seen that? You were like, planets photo. Who has not seen that? But I would say that the photo was released on 2015. It is very recent. 2015 only, by the NASA's New Horizons spacecraft that reached Pluto and captured that high resolution image. Before that, we were using Hubble or any telescope like that to image a very low resolution and blurry image of Pluto. But because of that New Horizon mission, we were able to see it in full HD details, and that too very recently in 2015 only, just 5 years back from now. So that's also one thing to be made. And the New Horizon mission, if I am not wrong, was like a very roller coaster, as in when it was approaching Pluto, some bad things happened to the spacecraft, but it quickly recovered from that. I can't remember the details as in what happened, but it quickly recovered from that and was able to get all those photographs. It was a flyby mission only. It wasn't any like capturing the in Pluto's orbit and doing some research. No, it wasn't that. Okay, Ken, it's not a planet anymore. Okay, it's not a planet. I see that, but of course there is so much of debate going on for that part also. That's for sure. The thing is, guys, going that far and completing all those things is a thing which needs some courage and some high level of knowledge, and accomplishing that milestone only itself is very crucial and very interesting and to achieve. Pluto is very beautiful, and we have also okay, so there's one joke also that we have one hard kind of a lake in Pluto which is frozen due to its temperature, as it is very far away from the sun. But that Pluto's hard kind of a lake is white, right? So everyone is like, every other thing is kind of a red, but heart is white, and that is because we are always doing considering Pluto as a planet, and then next day we don't consider it as a planet. One day planet, next day not a planet. So because of that, the Pluto's heart has been so depressed that it has gone white. So yeah, that's the one joke which was going in the internet. But yeah, Pluto is very beautiful to see and picture itself. It's a very unique planet itself. I haven't seen such a planet of course in this solar system. And with just few seconds of flyby, we were able to picture it. So we were able to get so many pictures, and also we were able to you can say get the composition of the Pluto, as in what it has and what it is made up of. We learned so many things with just a few seconds of flyby. So yeah, that's one thing. And right now, though, I am specifically very excited for those Mars missions which have been launched. Those 3 Mars mission, Hope Mars mission, China's Tianwen-1 and Tianwen-1, yeah, and the NASA's Perseverance rover. And I wish all of them become successful so that we are more closer to our habitat in Mars. Telstar 1 and 2, I have heard about it, but I don't know much about it. What was a Telstar? Were they any communication satellite? Oh, they look like a disco ball. I didn't know about this Telstar satellite. Well, I will surely do some research about it. And High River Racer, you just said one thing which I would like to tell, that one company is doing this only, High River Racer, bringing back the Apollo spacecraft which they left there. You can say the rover, they left one rover there, right? One company is doing some research and making all those things to bring back that Apollo spacecraft rover back to Earth for research, as in for the radiation effects and all on the materials. Yes, Ken. I Telstar. Okay, I will research about it. But yeah, they must be still in orbit. Thanks Blues Traveler always for all those information which you are providing right now. Yes, High River Racer, really. Yes, one company is there who is trying to recover the Apollo's rover, and they are working with NASA for that. NASA is also interested in that because they want to study the effects on the material, radiation and all those space environment on the material, because finally they will be sending the Mars mission, right? A human Mars mission which will last around 9 months. So they want to test everything. What are the effects on the material for the sun and all. So yeah. Yes, Blues Traveler, that Telstar looks like a Death Star.
Welcome back to the webcast for our 11th
Wow.
Starlink mission. We had an on-time liftoff at
We catch the
10:31
pairing.
a.m. Eastern Time from Cape Canaveral, Florida, for a 6th mission for this particular first stage. We landed it successfully on our drone ship, and there, as you can see on your screen, we successfully caught one of the fairing halves. That is a recovery vessel, Ms. Tree, caught that out of the air. The second fairing half made a soft water landing, so Ms. Chief is en route to scoop it out of the ocean. And before we went for a break, we saw the successful deployment of the 3 SkySat satellites for our customer Planet, which were ride-sharing along with Starlink. These 3 SkySats will be joining the 18 already on orbit and will complete Planet's fleet of 21 satellites and make it the largest high-resolution fleet of satellites in orbit to date. So here in just a couple of seconds, we will be deploying our 58 Starlink satellites, which will be joining the nearly 600 that are on orbit. Now, there is a chance, and it looks like, yeah, I was just going to say that
Starlink tension rod separation confirmed.
we have an expected loss of signal over our ground
And
station.
here
There
we
we go.
go.
We can see the visual confirmation of Starlink deployment.
Starlink has been deployed successfully, guys. Hence, this mission
Like I
is
said before,
successful.
those 58 Starlinks will be joining 600 that are already on orbit.
As you can see, they are
And
separating.
shortly, they will be deploying their solar arrays. Over the next few days and weeks, they will distance themselves out using the momentum created by the second stage.
Maneuver complete.
Like I said, we spun it along its central axis to provide the momentum required for those satellites to space out,
Wow,
as you can see there.
You can see the
So they'll be using
engineering
their onboard
solution.
ion thrusters to make their way to their operational orbit of 550 kilometers above Earth, and we'll begin to start beaming down high-speed internet to us Earthlings.
Wow. Exactly. So
And with that wonderful view of those Starlink satellites floating out into space, we will now bring our webcast to a close this morning. We'd like to thank our customer Planet for their continued support riding on board Falcon 9, as well as the FAA and the 45th Space Wing for supporting today's mission. If you're interested in getting future updates about Starlink launches, as well as general updates about future service availability, head over to starlink.com, sign up for updates, and we will see you next launch. Until then, have a good one.
and guys, we were okay. So if you are talking about space music, then the Voyager already has some musics from all over the world in it, and it has already crossed the solar system. Voyager 1 and Voyager 2 also has crossed, yeah. So yeah, so guys, we just saw the yes, Blues Traveler, thanks for that. What was the thing? Yeah, yes, we just saw, guys, the successful deployment of the Starlink satellite. As we all know, if I conclude today's stream, we first saw all those visuals from the Falcon 9 on the launch pad with all those clouds and coming out of it, and the sixth first stage booster, sixth time the first stage booster is being reused. That was very interesting. Then finally we have a beautiful lift off. Of course, I thought there could be, believe me, in somewhere in my heart I was like, this mission could be a failure just because they are using it for the sixth time. And but everything, to my surprise, went so smoothly, flawlessly, and we were able to even see the landing on the drone ship, which happened so gracefully. And then finally all those satellites, the SkySat first, and then the Starlink, and of course the information which you people gave me, and I commented, and I gave you some information. We basically exchanged information. So yeah, that was so much good thing. And guys, if you want, I can be back with the STV9 undocking for the stream. If you want that, I can do that for you. uh, and thanks Blues Traveler for everything. Okay, so I'll see if I'll be there with the uh, this undocking of STV9. But till then, stay safe, stay healthy, and bye bye.